So the session for today is primarily focused on MapReduce, but what we'll be quickly going back is understanding, few minutes, quick understanding about what Hadoop in general is trying to do. It pretty much has two components within it. First is the storage component, where we are storing the data, storing the files in certain form and format. And for Hadoop, that storage part is going to be HDFS, which is Hadoop Distributed File System. On the processing side, which is where you're taking this data, trying to make useful and meaningful things out of it, you use the MapReduce algorithm. And these are two primary components which in Hadoop ecosystem which we have. And there are several other components which we talked in the previous meetup, which take part and make it the complete Hadoop ecosystem. But these are the two primary ones which we start with. Our session today is primarily going to be driven on MapReduce. We're going to focus in deep dive around all MapReduce related stuff only. Let's get started. MapReduce in a fun way. As I said, MapReduce is considered as one of the most complex topics within the big data space. So trying to simplify it, that's my goal. Hopefully, let's see how much we can do it and achieve it today. So first and foremost, Hadoop is a team play. You start with this visualization, which really sums it up pretty well, what Hadoop is trying to do. Of having one large server which is trying to do all this processing, what Hadoop has really approached taking commodity hardware or smaller servers, which in all together, when clustered together well and built rightly, it could really do magic compared to even that single large server. And this pictorial view, I think, sums it up very well. That's why I call Hadoop is a team play. And we need to understand this before we go into MapReduce. And that's why I want to take a few minutes to just build the part of understanding as what Hadoop is and this team play part of it is. To understand that, I'm just going to take examples. Most of the time, we are just going to go through examples and scenarios to make it simpler and digestible for everybody. So first part, which we're going to dive and understand, this part which I was trying to introduce about how that Hadoop is a team play. So let's say I'm having this pack of cards and I need to find the Ace of Spade. And if I'm going to do it myself, all alone myself, I have to go through all the 52 cards, shuffle it, look it around, and it may take me a couple of minutes. So that could take a couple of minutes. So that's where I'm just doing it alone. That's a sad face over there. That's not the approach which we have taken, and we build something as a team effort. And instead, we do it together. If we are able to do it together, instead the data is structured, or these cards are structured in such a way that each of us, let's say 52 of us are there, and each of has one card as well only. And if I ask that question, who has the Ace of Spade, the person can instantaneously answer within seconds. And that's where we have seen the power of parallel execution. This is a very basic and simple example which shows how working together, we can get the processing improved from multiple minutes to a quick second. So just a precursor about parallel execution, because that's the building block or the secret sauce within Hadoop and MapReduce. Let's go into the actual example of MapReduce. I think that's a useful component to understand parallel processing, and then we have to go with the MapReduce. At the high level, MapReduce has two parts. First is the mapper phase, and second is the reduce phase. I'm not going to talk much detail about these phases at this point of time till we go through the story, the example, and then we'll come back and talk. But I just want you guys to know at this point of time, there is a mapper phase and a reduce phase. Most of the people who have been in the industry, reading about it, exploring about, they're already aware of it. But there is something in between. There is a part of which is called as short and supple. So this is the gradient which is happening in between the two phases. The transition from the mapper phase to the reducer phase happens through short and supple. And we'll talk about all of these through a simple story. So as I said, we are going to try to make it simple and fun. So let's talk about the story. And it may not be a story, an example maybe, what I would call as. Understand MapReduce with playing cards. So today is the day of all playing cards. So we talked about one example of playing cards. Let's go for the other one. So MapReduce with playing cards, what we're really trying to do here. So basic terminologies, as you know, a deck of playing cards would have 4 suits, diamond, clubs, heart, and spade. You should know the rules of the game before playing. So let's say we imagine a situation where we have a mess of 50 playing card decks. And so it's all scattered across, and each of the deck, as you know, may have 52 cards. And combined together, this should be a pile of 2,600 cards altogether if everything is together. So that's what our input data is. That's our starting point. Goal is to really find there are potentially some missing cards from this pack of 2,600. There are some decks which are missing. What we really want to achieve is to really find which particular cards are missing. So for example, 48 of this diamond ace really tells us like two cards of that kind are missing. And that's what we want to find. So this is our input, this is our expected output. And let's see how, using this example, we are going to really understand MapReduce. Step one, always when you have a big task, what you do, you ask your friends to help. That's what friends are for, and that's what we do. So that's our first step. What we're going to do is really call our friends to help. And typically when you have friends, there are two categories of friends that broadly if I would have divided here. And one of the regular friends, and then I have some geeks. I've named them A, B, C, D, which are our 4 regular friends. And on the Greek side, we have called them hash and dollar. They are numerical files, they play with numbers, work with numbers, and that's why they are called the geeks. So these are the category of 2 friends which we have called to really help us with this problem of the deck of cards. It's a lot of cards. It's a lot of cards. As all of the cards are present, we are talking about 2,600 cards to deal with. So individually, me doing it or one person doing it could be quite a lot, and that's why we have got our friends. So what we do, first we assign our regular friends, the A, B, C, D, to take some part of the cards. It's not necessary they have to get an equal part of the cards from this pile, but it's just divided between them in certain format and structure. So that's what we have done. These are divided into the 4 regular friends across. Step 3. Each of the friends has been asked to do, taking their pile of cards, they are supposed to organize this and find how many cards, just arrange in certain order. Certain order being like they would take the suit and follow through the sequence and just keep on piling all club of ace one top of other in their pack of cards. So each friend is trying to do the same process, and individually they're just doing for their own pile of thing, and this is what they would result after all of them have completed. So A, B, and C, D, all of them have done their work, and this may be potentially the outcome which has come. It's not same. It's not necessary they will all have all kinds of cards. For example, C and D seems to have the full pack of cards and several of those, but A and B have some of those cards, and some cards are not in their pile. So it is perfectly fine because they got randomly selected set of cards, and that's what they worked with it. So this, in the big data world, is which we would tie to the phase of the mapper. There are several nodes. This A, B, C, D can be considered as nodes, and they get a huge task of work, which is divided in certain fashion to them, and they individually parallelly work to achieve that particular task. So this is our first phase, the mapper phase. This step, what we are going to do is take one user's data, so let's say A's data, and we are going to put all of its cards on the other pile. So for example, if I had this 4 of diamond, 4 of the hearts, I would put it on the pile of D, just collecting it together, and the 3 of hearts as well, so on and so forth. So that's way we'll first take A's card, merge it with D, B's card, set, and finally D, and this would be the resultant output. They all would be organized into a certain pile in one single pile, and that's the output together. And this organization of all these piles is what we call as shuffle and sort space in the MapReduce world. The data with using a single key is organized together. In this case, the key would be the suit and the kind of card which is having that. So we have 52 different kinds of cards and 52 different keys. They have all together arranged and been brought ready for the next phase, which happens to be the reducer phase. And reducer phase is all about numericals and countings and summations, aggregations, and who best would do that? It would be our geek friends, hash and dollar. So we have asked them to help out at this part of the process, and they have given certain parts of these things, let's say two of the suits are given to each of them, and they are going to work together their magic and really get us the result to give us the counts of each of them. Once they are done counting each pile, this is what the output which will be coming together. And they are only focused on the task of calculating those piles and giving us the results. Once we got this, what would happen, we will be able to identify that there are certain kinds of ace of diamond missing and so on and so forth. And now we have achieved the goal which we wanted to achieve through a simple example. What we have really walked through is the main phases of MapReduce. The mapper phase, shuffle and sort, and the reducer. Say round 2, it normally happens, right? When we have these cards and again they get mixed up together and again we have to call our friends and do the same exercise again. So next time when we call our friends, the regular friends, A, B, C, D, they are a little annoyed or at this point of time saying like, we can do counting. We don't only need to really wait for the geeks to really be able to do that. So to achieve that, say, and this is basic mathematics, we can do the counting. It's not great or complex algorithms which we are solving here. So I can do that. So what in this round 2, what they are doing is they are counting their own pile before giving it to somebody else. And this kind of a structure helps, and this is called as a combiner. A combiner is an optional component within the MapReduce concept. It not necessarily has to be part of every single MapReduce program, but it can be brought in for performance improvements. And if you notice that the performance improvement is going to come in because A has already done some amount of calculation to that, and what reducers have to come in and really add up the final amounts which have been already counted. And they have to just add up these 4 amounts. So it makes life much easier for the reducers, and this time work can be divided by more people. And that's why this is the optional combiner, purely for performance reasons. A caveat in the combiner, it cannot be used in every scenario. It cannot be used in situations where you're using average, median, and so on and so forth, because a median of 4 different numbers together, median of median does not come a right answer. So it can be used in count or summations and these kind of situations, but we'll be having the same output. The result is going to come together same. It's only for the performance improvement. So I just wanted to bring in the concept of combiner using the same example now which we have understood, and bring in that as well as in the mix. It together. Here is the MapReduce flow. We had an input data for us, a pile of 50 different card decks, and we did the mapping. The individual friends did the mapping for that, and in the second round at least there was an optional combiner which they used. Shuffle and sort happened, and it was given into the reducer to really produce the output and understanding, segregating the data in a correct way, as well as providing us the way to group it together and say the answer which we want to answer, how many cards are missing in particular deck. So that was a quick summary about, and I hope it was an easy way to really come through understand about what MapReduce is doing, and it's making it a little